Good morning, mathematicians. Hope you're all doing well. Yes, as you can see, I got a new haircut. I don't know if it's my favorite. I'll be honest with you. What to yap about today? That's always the question. We haven't been doing Reddit news as much because we've had actual problems to work on, which is better. Hello, Edit Smith. It looks like you're coming back to your your reign as first in chat. You were slipping there for a while, but I think the title is yours again now. Yeah, new haircut. Yeah, I'm not crazy about it, I'll be honest. Opinions on Mass Stack Exchange. Just want to solicit some current opinions on Mass Stack Exchange. I used to frequent it and loved how freely people traded and shared ideas. Least upper bound? I don't know what you're referring to, Z. The grand scheme of things is immediately... some high school student asking about a simple observation they made. I see. But it was immediately closed down. I see. Instead, they're pointed to a duplicate of the problem that is much more abstract and probably not as useful to the kid. Is this the culture and end goal of Mass Stack Exchange? Yeah. I don't know. Oh, sup. Oh. Okay. Yeah, I'm slow. I'm definitely gotta get a bit more gotta get a bit deeper in this coffee. Yeah. I think this is true. Like, I don't know. People can be too abrasive. I don't know. We don't want to like necessarily scare off this curious high schooler. That is something, to be cautious about. Damn, this plant over here is looking thirsty, actually. But also, yeah, at some point, like, I don't know. Mass Stack Exchange isn't supposed to be for every level, right? There's like Stack Exchange is like roughly undergraduate level mathematics, and the goal is to try and keep things, not too below, not too above that. Yeah. But it is also important. It is important to know this, and yeah, I mean, yeah, it's hard to know without seeing this exact example. It's hard to pass judgment and say whether the moderator was in the right or not. Oh, this is interesting. I briefly looked at this the other day. Recently read about Lever spaces to give good morning tenacity. Good morning. Nice one, Dayson. Wow, Z and Daysen, you got some good game going on here in your greetings. At the same time, led them to question why this object is so special. Embedded in the definition of metrics and measures. This was spurred by the fact the real numbers do have a uniqueness property, being unique ordered field, yeah. But neither metrics or measures use the field to nature of R. That's true. You have a topic. You wanna? Yeah, of course, of course. There's never any need to ask if you can share a certain topic or ask a certain question. Just ask it. Worst case scenario, I don't feel like talking about it, or I don't know how to answer it, and then I just skip it. What seems too pedantic could actually solve the asker's doubt. Yeah. Yeah. I mean, that's true. That's true. But then I don't know. Maybe this seemingly abstract, seemingly unrelated abstract thing pointing them towards it will could also do that because it connects them to the like pedant version of the problem. Yeah, I don't know. Used to have a G, but then he passed away. After we had Levere, but then he also passed away. Who do we have now? Well, I don't know. Who are you? Oh, Pope. Yeah, Pope Leo. Yeah, exactly. Yeah, discussion done. That's the right answer. I don't know. But I'm curious. I mean, from that message, I mean, it seems like you're putting Levere and Grothendieck on the same level. Um, I don't know. Is that a thing to do? I'm not super familiar with like everything Levere has done. I know he's done some like crazy stuff, but like, yeah, is it really comparable? I don't know. In my mind, Grothendieck's the number one goat. Can't be topped. Or maybe he could be, maybe one day, but I don't think he has been. This is interesting. I mean, certainly topologically, there's probably a way to describe 0, 1 with some sort of categorical property. Oh, that was a follow up to the comment you posted that didn't go through. Stack Exchange. I knew it was Stack Exchange, but feels snobby. Yeah, yeah, it can be that way. Um, wow, For the most part, I actually haven't experienced much snobbiness on there personally. Not to say that other people haven't, but with the exception, I did have this one question. I don't remember what it was. It was about like Langlands. It was about like local Langlands. Hi, I was about like local Langlands for PGLN. Actually, maybe I even have the question on here. Or was it on Overflow? Might have been on Overflow. Um, how do I see my questions? Profile? Go to my profile. Bro, what do I think about Teichmuller theory? Well, are you asking about Teichmuller theory or are you asking about inner universal Teichmuller theory? I actually can't comment on either. There's a whole branch of Yeah, math called Teichmuller theory, and I know basically nothing about it. Um, yeah, what was I asking? Yeah, so here's this question. Here's this question. Yeah, it's asking about non-Archimedean local Langlands, and how it should, yeah, just reduce to the case with GLN. Uh, has it been worked out somewhere? Which, okay, it is pretty straightforward. There isn't as much to say. But then I think maybe it was in the comments or something. There was somewhere where like I asked about the Langlands. Maybe this wasn't it. Here I'm just asking about the structure of PGLN. So there was somewhere I asked about like um, the Langlands. You know, if anyone had written up the Langlands correspondence for PGLN, and then someone was like, "Oh, it's so absolutely trivial. Like, why would anyone bother doing that?" In the comments, and I'm like, I mean, technically, in hindsight, they're not so wrong. It's like if you know the Langlands correspondence for GLN, and yeah, you just realize that there's this equivalence of categories, then like, yeah, everything should follow like pretty immediately. Um, but still, I don't know. What a terrible comment to make. My research area is in the local Langlands program. Speaking of, so I do a little bit of representation theory of p-adic groups. I do a little bit of like differential geometry, sort of some algebraic geometry. Even though the last couple days on stream we've been doing some problems, and I was making very, very silly mistakes in very basic algebraic geometry. It would be fun to see the Pope do some category theory. Yeah, I want to see the Pope's old homework. That's what I want. Do I watch the struggling grad student on YouTube? I think I've seen his videos. That's the Simon Cowell. Hello, hello. I think I've seen the struggling grad student. That's a guy. He's got like a gamma, a little lowercase gamma in his profile, and he is doing analysis. And makes videos on his journey. Yeah, I think I've watched some of his stuff. I wouldn't say I follow him super closely, but definitely aware of his stuff. And I've definitely thought about making videos along the same lines, like typical life in the day of a grad student or something, typical homework or something. Actually, that is a good series. I should go through all my courses and my homeworks, which kind of I'm a little bit going to be doing in the Your Proofs Are Trash series. When people say differential geometry, do they mean the pencil-heavy surface, stuff in R3? I mean manifolds. I think most people mean manifolds when they say differential geometry. Maybe I can get my guitar and see if Simon can get me to Hollywood. Yeah. Well, is it time already? I guess it is. What are we talking about today? I don't know. We don't. No one's. We don't really have a topic quite yet. You know, I've just been looking at Reddit so far. No one's asked any math questions yet in chat. Very non-intuitive stuff. Never got algebraic geometry. Plan to get into topology. Well, topology is a good place to start first. The thing is, so I actually claim that a lot of stuff in algebraic geometry is fairly intuitive. It's just, for example, like if you go open up the most modern treatment available today, and you just crack open a random book on schemes or something, then yeah, you're gonna be like, this is all abstract nonsense. Why would anyone do it? But I guarantee there is a way to teach algebraic geometry that does make it intuitive. But it's maybe not the quickest way to get to the modern thing, because I think it's, the best way to sort of, not the best way, but I think one way to get an intuition for it is to sort of tell the historical story of how algebraic geometry originated, which means talking a bit about um, functional analysis, talking about classical algebraic varieties, learning some differential geometry first. I see we got a lot of questions popping off in chat here. So, the other day, saw this kid on 17 on Reddit, and he's like, I'm doing work in algebraic geometry, and I've read Shafarevich, blah, 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 all in 1 year. I don't want to be a hater, but come on. I hate these kids talking about fancy math, but they can't even do a simple exercise from Hartshorn. Yeah, maybe. I mean, hey, look, I've definitely met people who are legitimately brilliant. So it is entirely possible that this kid, uh, this 17-year-old, could be doing those things. Entirely possible. But I've certainly met my fair share of students who talk way beyond what they can actually do, and it happens at all levels. So yeah. Mm, Vincent is a physics major, thinking about going into mathematical physics. Any idea of math classes to take in between to help prepare? Well, I'm not in mathematical physics, but but uh, I would say what is good. There's a book. Crap. Maybe I should run to my room and get it. There's this physics book. It's called like Differential Analysis in Physics or something, or like Manifolds for Physicists. I think it was written by like three women in the 70s. I don't remember their names. Damn, but it was like I think if you just like Google those sorts of terms, it'll come up. But it was good. It looked like it had a lot of stuff for physics and everything. Of course, this depends on what you're going into in physics. I mean, I always say for everyone, master the basics of linear algebra really well. Every linear transformations, diagonalizing matrices, um, Jordan normal form decomposition. Just like get good as hell at the very basics of linear algebra, and probably and also doing like calculus on Rn. I mean, you'll want to do calculus on manifolds as well, but I think if you really like just the basics of calculus on Rn and linear algebra, and hammer these really well, I think having a strong foundation in these things will make it easier for you later on down the road. So I think mathematically those are good things to have. Um, yeah. Yeah, I'm not sure. I'm not sure what else. I'm not sure what else to say, unfortunately, about what would be good for a physics major. And probably those things are going to be different. Like probably for quantum mechanics. Well, mind you, I guess actually, obviously, no matter what you do, getting good at your differential equations, brushing up on your basic differential equations, um, probably going to be useful as well. But like I imagine the theory you need for quantum, probably more stuff about like statistics and stochastics and Hilbert spaces and general relativity, probably more like Riemannian geometry. How should you improve in combinatorics for Math Olympiad? I have no idea. I have never been good at math competitions. I've participated in a couple with very poor results. Uh, yeah, I've no idea. There are probably much better places on the internet to go than here to answer that question. Unfortunately, I can't help you with that. Um, One thing you always want to look at is planar curves. Well, you should go look at them right now. No, wait till the stream's done, then go look at them. If you know manifolds, then schemes are quite intuitive. Yes. Yeah. My supervisor seems to have been fine being just raised purely on schemes. I've said this many times before on the channel, but I can't get my head around it because I'm like, well, but so much stuff about schemes would not make sense to me if I didn't know some differential geometry first. Compute the first étale cohomology. Oh God, I don't think I can do that. But maybe I'll. Well, maybe I'll write it down. I'm not gonna. I definitely can't do it live here today. But I'll put it on here. Compute first étale. Why am I even writing this? Of spec z 1/2 with coefficients in z mod 2. That's not a bad thing to learn how to do. So I'm gonna put that down, but I definitely can't do it live on stream from out of nowhere. How would I show an orientable manifold admits a non-vanishing section? Well, you could. I think if the first Chern class is trivial, that would do it. If you prove the first Chern class is trivial. How do you actually do that? Well, I don't know. That's more. It depends on your vector bundle. You could either take the axiomatic approach, which I'm not so familiar with, or like I've talked about, we've got you can take the total Chern form and look at the degree 1 piece. Exponentiate the curvature and take the trace, and then look at the degree 1 components, and then see if that's an exact form. If it's exact, then that should imply that C1 is 0. I believe. Don't take that as gospel. Wow, chat is really still popping off down here. I'm like so far behind. And I'm gonna pause for half a second too, because to be honest, chat, I really need a piece of chocolate. So I'll be right back. Dark chocolate and coffee. It just hits so well. Okay, here's a proof of Euclid's theorem that you would like to turn into better estimates of pi x. Let pi p1 to pn be the primes. Then for every n less than n is of that form. Wait. Your notation's a little... I see. Okay. So we've got P1 up to Pn, and those are all the primes less than big N. Okay, agreed. Your notation, though, I think you should have said for every little m less than n, because you don't want this little m to necessarily be the same as that n, right? Is of that form. Sure. And then taking logs, right? So you get a sum of of AI log pi less than log n. Therefore, the number of solutions to the inequality is exactly equal to n. I don't think that's true. I don't think that's... is that true? I don't think that's true. Yeah. I don't think that's true. What else? What else do we have? Yeah, maybe if you can clarify how that follows there. Tenacity asks, do I like number theory? Yes, I do. I mean, I work with p-adic numbers daily. Strictly speaking, that's not number theory. Well, depends who you talk to. I like to tell people that I'm legally allowed to call myself a number theorist, even though I do geometry all day. If we can estimate the number of solutions as a function of pi x, or some log p, we should be able to bound it. One professor you had calls calculus and Rn the primordial boo-boo. Well, as in it was like a mistake, like a fundamental mistake, like we shouldn't have done it? Or what? Or was that where he was hurt by math for the first time? Hello, Super Baron. Sorry I'm so late to saying hello. I've been higher up in chat. Combinatorial problem-based approach. Sorry, I don't know what that was in reference to. I think that message was from a while ago. Bro, prove that the fundamental group of a circle is isomorphic to the integers. Yeah. Yeah, that would take an hour or so. Actually, it depends. Where am I starting? Am I allowed to assume covering space theory? And then just prove that R is the universal cover? Because that would maybe make life easier. Also, by the way, I saw when I went to, I don't remember how the proof goes, but actually in homotopy type theory, the proof that the fundamental group of the circle is the integers is like basically trivial. I saw it from this summer school I went to on homotopy type theory. Yeah, I don't remember how it goes, but yeah, basically it's because like it's like the way you define the circle in homotopy type theory is to be like the space generated by a single loop, and so it's like it almost comes out like by definition, but there isn't really a better way to do it. I mean, the kind of one of the goals of homotopy type theory is to be a synthetic homotopy theory, so you know, one would maybe expect those kinds of things to fall right out of the proper definitions. Does Milner's topology from the differential viewpoint resemble any contemporary field? Probably differential topology, I would have to guess, but I have no idea. Oh, it's quite old-fashioned? Okay. I could also believe that. Notes on the combinatorial fundamentals of algebra, free book. You have to Google it and find the latest on the author's website. Oh, maybe that's, yeah, you mentioned that book before, but maybe that was in response to the student who was asking about, like, combinatorics and improving at the Olympiad. Although, is that a good book for the Olympiad? Just wanted to hop into shitpost. Hell yeah, we're here for it. Accomplishment of this duty laid out to myself by myself shall here be understood as achieved. Godspeed, Gweth. Efurf. I think that's how you pronounce this. Efurf. Fundamental theorem of arithmetic guarantees us that the solutions of the inequality are one-to-one with the integers less than n. Stream is super leggy, so you're going to drop off. I don't know if the stream is super leggy. I mean, it's maybe a little bit leggy, but it's the fact that I'm just so far behind in messages. No, wait a second. Maybe you're right. The number of solutions. Sorry, my apologies. I do understand now. I don't know if you're still here, but right. Number of solutions to this is n. I'm with you now. But wait a second. Is this not deriving the log n over n estimate? This somehow seems too simple. But maybe that's right. I thought proving that estimate was more difficult. As he thinks that's where most get hurt or haven't properly mastered the field. That was in reference to the boo-boo thing. Guys, I'm kind of excited. We're almost at the threshold where chat goes too fast that I can't answer everyone's questions. Which is, that's great. That'd be like the dream. I mean, it's sad in one sense because I want to answer everyone's questions. Okay, I like this question. I like Tenacity's question. Find all solutions. Find all solutions to the totient function being equal to 16. I like that. Sorry, someone was asking for books on combinatorics. Yeah, right. Bro gave you an example of a symplectic manifold. Nicole, you have a question. Well, while you're typing your question, it is song time. No, I don't like not those chords, Jesus.
Chad is finally getting too busy to keep up. Seems like just basic algebraic geometry isn't enough. I've got to keep on working on my research every day. But maybe I should just live stream my degree away.
Yeah, I really got to get a little, like, ukulele in my office or something for when I'm streaming there, so that I don't ever skip song time. Ooh, can I talk a bit about representable functors and the intuition behind it? Yes, absolutely. Right after we do this basic number theory problem. But let's first remind ourselves, what's the formula for the Euler-totient function in terms of the prime decomposition? What is it? Aha, right. So if we take the factorizations, it's that. So, right, what do we have? So that would mean that 16 is P1, K1, P1 minus 1. Is that right? Yeah. Oh, K minus 1 times P2 minus 1 dot up to Pn, Kn minus n, Pn minus 1 But now, I mean, 16 is even, right? So there can't be any odd factors. So I am familiar with the Yone dilemma. Oh, are you asking the Nicole? Maybe you're asking Nicole as a means to answer her question. But I will yap about all of that in a moment. So what does that mean? So the only possibilities are coffee's about to run out. Gotta get the questions in quick. Oh, that's true. Nerd Coke's paying attention. So what does that mean? That means that well, for all of our prime powers, so let P1 let's say is 2, right? So for all other for I bigger than or equal to 2, we know that K2 has to be at most 1, right? Because we need to make sure that any odd numbers are getting killed here. We also have to make sure that these primes, because 16 is just a power of 2, that 1 less than all of the other primes are just a power of 2. So, wow, we might even be able to just like brute force the rest of this, though, right? So of course, one possible solution is if I guess k minus 1 is 4, and if k minus 1 is 4, which is to say n is 16 itself, right? Because 5, 16, according to this formula, would be 2 to the 4 minus 1 times 2 minus 1 would be, oh, no, sorry, it should be, sorry, not 16, 32. So this would be 2 to the, this should be 5, 4, there we go, 16. Nicole is learning about the Yone dilemma, but haven't exactly mastered it. Got to bounce, y'all. Oh yeah, have a great Mother's Day. Yeah, by the way, why the hell are any of you here? You should all be if you still have your mother on this planet, you should go hang out with your mom. I still have my mother on this planet, so I'm gonna call her. I did send her a text this morning, but I'm gonna call her. Right. So I guess so then yeah, I would just go through just consider the other cases, right? So let's suppose this is 1 lower. Let's say k minus 1 is 3, which is to say that we have k1 is equal to 4, right? So that would mean that whatever our number n is, it has in its decomposition 2 times 4. And we know that phi to the n. You're hanging out with your mom right now watching the stream. Oh, hello, Mrs. Edit Smith's mom, if you're listening. Happy Mother's Day. Happy Mother's Day. I feel like that's the ideal. Actually, I should have mentioned this at the beginning of the stream. I should have said, go, get in touch with your mothers and have them watch live stream with you. What better way to have a bonding moment with your mom than doing some math together? Okay, so what are we gonna have here? Phi n. So this will be 2 to the 3. We want this to be 16, right? And so, well, this 2 to the 3 is going to give us an 8. Whatever the other factors turn out to be, it's going to have to be a 2, right? So The best we can do, then any other prime is going to be too large. The only other possibility is to have this. Oh, Mother's Day was yesterday for you in Australia. Ah. Well, hopefully you had a very mathematical Mother's Day. So the only other possibility is if we have, of course, a 3 minus 1 showing up here to give us that extra factor of 2. And then this, of course, would have to be 3 to the 0, which would mean that, K2, let's call it, minus 1 would be 0. So K2 would have to be equal to 1. So, in other words, our next solution... So what was our first solution? No, it shouldn't have been 2 to the 4. It should have been... right. So our first solution was 32. We find that our next solution is 2 to the 4 times 3, which is 16 times 3, which is 48. God, I can't do like basic arithmetic. Chat, you gotta fact check me here. Hello, Arcturus. Okay, what else we got? Yeah, I don't know if I want to do the rest of this question. I feel like I want to just address Nicole's thing. I mean, you all can see where the rest of this is going, right? I guess actually, yeah, that's an even better point. Well, okay, I would just keep this crunching this up by hand. Simon is still here. Wow, super leggy. I think it's just that leggy on your end. I could be wrong. Studying for an exam. Just have me in the background. By the way, meant leggy in the sense of internet connection. Ah, I see. This method doesn't produce sharp estimates unless you have really good ways to estimate the number of solutions. Yeah, that's one thing. I wish there was like a proper analytic number theory course where I am. I mean, I'm far done with courses now, but I would definitely sit in. On some analytic number theory courses. But yeah, anyways, I would just play the same game, go by descending powers of 2, and see what's up. That's basically it. Yeah, that's basically it. So, before my coffee's done, I will address Nicole's question. So, one of the things is, what was the exact wording of the question? I mean, it's about like the functor of points perspective, right? Yeah, representable functors. So yeah, the Yoneda lemma tells us that we can basically embed our category into the category of pre-sheaves, right? So we can take by sending an object and sending it to this functor, right? What is the cohomology of the Klein bottle? That's also an interesting question. Okay, so things to remember for the future. Not that cohomology of Klein bottle. We could definitely compute that. I'm not going to be able to do it today on stream before my coffee's done. But let me put it for future to compute the cohomology of the Klein bottle. We'll definitely do that in a live stream soon. So the Yoneda lemma, right? It basically, I mean, part of the idea is that this is like a faithful embedding, right? So we can realize our category as as a subcategory is like a full subcategory. Full? Yeah, full, because I guess the Yoneda lemma. This is the Yoneda embedding, and the lemma tells us, we've got this isomorphism with the natural transformations, and the points of like the image or whatever, and so then this means we can realize like functors, contravariant functors out of our category, or covariant. There's a covariant version, as sort of generalized objects, right? And so this means then now we can work with objects as functors if we want, and then have the tools of functors available to us. But it also means that we can like phrase certain problems as functors. So like there's so-called like moduli problems, or like moduli spaces, and we can try and ask, for example, for some sort of space whose points parameterize something, right? So like I have some very old videos talking about what would be called the coarse moduli space of elliptic curves, right? It's this fundamental domain in the upper half plane, and each of the points in here, corresponds to a different complex elliptic curve, and yeah, each point is a distinct complex elliptic curve. Okay, you got to be careful about like the boundaries and stuff, but and so what you can do is there's a way, I can't remember, I can't do it off the top of my head here, but there's a way that you can formulate like moduli problems in terms of basically in terms of functors. And then the thing is, so you can talk about a functor as some sort of like solution set, right? And then you can formulate this in terms of some like contravariant functor from your category that basically takes you to some like solution set of your problem. And then you can ask, well, is this functor, is f representable? Is f representable? And the idea is, well, if yes, then that means that there's that like f being representable means exactly that there exists a space whose points parameterize what you're interested in, right? Like for example, in like ordinary topology, there's a space. Okay, now I'm talking about things that I don't really understand, so beware. But there's this space BG, which is the God, what's the name? It's a classifying space of principal G bundles. And like the point is that we have a theorem, so there's some sort of free contractible space over BG, and there's a theorem that basically says all of your principal G bundles over X can be realized as a pullback of some map. And in fact, the principal G bundles on X are in bijection with the homotopy classes of continuous maps into here. So basically, it's like the hom. I mean, I guess from the homotopy category, naive homotopy category, maybe, and okay, there's definitely imprecise things here, but like this essentially this functor corresponds to parameterizes your principal G bundles. Can you use classifying groups of classifying spaces of groups? Say, yeah, that's exactly what's going on here. And so like BG is a space that like literally solves this for us in ordinary topological spaces. But then sometimes life is more complicated, like in algebraic geometry, and you end up having to go to a stack instead. I mean, there's a stacky perspective on this, but here, I mean, for just sufficiently nice topological spaces, you can just literally create BG. Okay, lots of stuff going on in chat, but I think this is I think where I'm gonna call it for today. Let me just quickly look at some of these other things. Planning to have a series of blog posts which sketch the traditional approach to the prime number theorem. You have a draft for the outline. Interested in having a proofread sometime off stream? Yeah, you know what? Send me. I don't know if you're still here, Simon. I'm sorry, I've been so slow in chat, but yeah, send me an email, ktheorytutoring@gmail.com. I'd be happy to have a look at that. If anything, it's an excuse for me to remind myself of the traditional approach to the prime number theorem, so that'd be great. Fun result. If there is a delta and 3 subsets of SL2FP such that the product of their cardinalities is less than the cardinality... Let me write down that statement. So if there exists a delta greater than 0 and 3 subsets of this such that the product of their cardinalities is less than or equal to the cardinality of SL2FP 3 minus delta, then, oh, interesting. I mean, is this used for like, what is it, the writing this as like the Borel subgroup decomposition or something? Do you use that trick there? That's kind of interesting. Can I explain what it means to mod out geometrically? Like, what is T2 mod S1? Yeah, I'm not sure what's being asked exactly. Learning about classifying spaces of discrete groups on your undergrad project. Nice, very cool. Does anyone know if Hironaka proof of existence of a resolution of singularities in positive characteristic was proven wrong, or what is up with that one? Oh, I don't know. Is there some proposed proof by Hironaka that Hironaka resolution of singularities Carpi? Well, I'm going to take a look at this, but I'm going to go. Proof of that fact uses Fourier analysis on finite groups. Oh, that is very cool. The idea is showing that the convolution of 3 indicator functions greater than 0 implies the result. That is so cool. If you can, maybe leave that in a comment on the video. I'm about to kill stream. I gotta go. I gotta get my life going. I gotta go prove some theorems. But that is an awesome result. So everyone, time to go prove stuff.